Hello, everyone. So in this video, I'm going to show you how to multiply and divide fractions. If you don't know how to convert mixed numbers to improper fractions, please review that beforehand. Also, if you are not comfortable with multiplying and dividing integers, positive and negative numbers, I would encourage you to look over that also before you start this. So multiplying fractions, the great thing about multiplying and dividing is that you do not need common denominators. When you add and subtract, there's no way to add and subtract unless those bottom numbers match. But with multiplying and dividing, you don't need that. In fact, that would just give you bigger numbers and make it more work. So I'm okay on this first problem with it saying 3/4 and 4/5. There's two options for this. One method, you multiply first and then you reduce. The other method, which once we get going, that'll be the one you see me do the most, is when you reduce first within the problem and then multiply. I always look for ways to get smaller numbers if possible, just to kind of lighten the workload for myself. So that's what you'll see me do, but both ways work just fine. So method one, like I said, is to multiply and then reduce if it's necessary. We're going to multiply both across the top and the bottom. I don't mean on diagonals. I mean straight across the horizontal rows there. 3 times 4 is 12. 4 times 5 is 20. That can be reduced. You can reduce them both by 4, and maybe you see right away that 4 is your greatest common factor. Or maybe you looked at that and you saw they were both even and you want to start by reducing them by 2's. That's okay. If you reduce them by 2's, you would get 6/10. But then you just need to recognize that 6 and 10 are also both even. So you can divide those by 2 again, and you get 3/5 for your final answer. I'll show you the other method in a minute. Let's stick with this way right now. So on the next one, I'm going to get bigger numbers, but that's okay. Some people would rather multiply first and then reduce. I know that when my signs are different, I've got one negative and one positive. That one negative is going to make the whole thing negative. So I've got a negative answer. Across the top, I'm going to do 6 times 22. And that gives me 132. On the bottom, 11 times 9 is 99. It may not look like it at first, but both of those can be reduced by 3. Sometimes if you're not sure, try 3, or sometimes even try 7. Some of those numbers, they don't look like they go in there, but they can be sneaky, so always check it out. I'm going to reduce them both by 3. 132 divided by 3 is 44. 99 divided by 3 is 33. And then I hope you notice on this that I can now reduce both of those by 11, or I could have reduced them both by 33 in the beginning. If I divide these by 11, I get negative 4/3. I've said in previous videos with fractions, it doesn't bother me if you leave them as improper for your answers as long as they're reduced. The only thing I would caution you on, if this is the answer to a word problem, I would much rather you make it a mixed number first. And the example that I always use is if you're remodeling your house and you go into a hardware store to get, whether it's flooring or maybe you're going somewhere to get wallpaper or some certain tool, and someone asks you what size you need and you say 4/3, you look like an idiot. So word problems, you want to make it sound more like a real world answer. Or if you're doing a standardized test, a state test, even a multiple choice test, it may be that you're required to make the mixed numbers. So to convert this, so I'm going to write, or it's still negative. 3 goes into 4 one time with 1 left over. So negative 1 1/3. Last one on this page, the parentheses right beside parentheses just mean multiply as long as there's no operation sign in between them. Those parentheses are just saying, hey, look at me, I'm a negative. So again, I'm just going to multiply across the top and across the bottom. I know that 2 negatives come together to make a positive. So I'm going to have a positive answer. 8 times 5 is 40. And remember, this is positive because the signs matched. On the bottom, if I do 15 times 9, I get 135. I know that if they end in 5 and 0, I can divide them both by 5. So I'm going to reduce by 5, and I get 8 over 135 divided by 5 is 27. That does not reduce any further. So that was option 1. Option 2 is to cross reduce. Now, while we don't ever multiply on diagonals, you can reduce on diagonals if it's possible. And you'll find that if there's nothing that can be reduced in the problem, then there's not going to be anything that can be reduced in your answer. If I look on my diagonals, 3 and 5, there's nothing that goes into both of those. But 4 and 4, I can divide both of those by 4. So let's do that. 4 divided by 4, cross it out and make it a 1. 4 divided by 4, cross it out and make it a 1. Now multiply across the top. 3 times 1 is 3. And across the bottom, 1 times 5 is 5. It's already reduced. I'm still doing the same math. It's just the first way I left the problem and reduced the answer. The second way, I reduced the problem, so then most likely I can just leave the answer. Plus, then I've got smaller numbers that I need to multiply. On the next one, we've already seen these. We know what we're going to get, but here's the way you can make those numbers smaller within the problem. We know it's a negative answer because the signs are different. If I look at 11 and 22, I can divide both on this diagonal by 11. So let's do that. Cross this out. 11 divided by 11 is 1. 22 divided by 11 is 2. And then this diagonal, 6 and 9, I can divide them both by 3. 6 divided by 3 is 2. 3 divided by 3 is 3. So now across the top, 2 times 2 is 4. Look how much smaller and easier that was. Across the bottom, 1 times 3 is 3. Or, like we said, you can convert that and make it negative 1 and 1/3. Same deal on this one. Now, on this diagonal, 8 and 9, there's nothing that I can do there. But 15 and 5, I could divide them both by 5s. 15 divided by 5 is 3. 5 divided by 5 is 1. Across the top, 8 times 1 is 1. Across the bottom, 3 times 9 is 27. That should be the exact same answers that we got on this page. It's just reducing before we multiply. We already knew that one was positive because the signs were the same. So there we go. If you have mixed numbers, you have to convert them to improper first. You cannot leave them mixed numbers to do this multiplication. When we were adding and subtracting, I showed you how sometimes converting them can save you from having crazy answers that don't work that you end up having to fix. Sometimes it can relieve a headache that might end up happening. But with multiplying and in a minute when I show you dividing, you just have no option. So I'm going to do that C method that I've shown you in another video, or if you're in my class, you see me do it all the time. 2 times 3 is 6, plus 1 is 7. Keep the bottom on the bottom. Times 5 times 2 is 10, plus 4 is 14. Keep the bottom on the bottom. So that becomes 7 over 2 times 14 over 5. You can multiply across and across and then see if it's able to be reduced, or you can cross reduce. Now, we talked about how you can reduce on diagonals. You cannot reduce side to side. I know it's so tempting to reduce the 7 and 14, but you cannot reduce side to side like that. So if I look at my diagonals, there's nothing I can do with 7 and 5, but 2 and 14, I can divide them both by 2 and make this a 1 and a 7. So then across the top, 7 times 7 is 49. And across the bottom, 1 times 5 is 5. If you need to convert that, 5 goes into 49 9 times. That would be 45. So then you would have 4 left over. So mixed numbers, you have to convert them first. If it's a whole number, you can make it into a fraction by sticking a 1 underneath it. So in this one, I'm going to leave it negative. 3 times 1 is 3, plus 2 is 5. Keep the bottom on the bottom. I'm going to make this 6 over 1. I know that my answer is going to be negative because the signs are different. You can get 30 over 3 and then change it. Or 3 and 6, I can divide them by 3s and make this a 1 and a 2. Across the top, 5 times 2 is 10. Across the bottom, 1 times 1 is 1. Even though that's reduced, it's not really written in simplest form, is it? Negative 10 over 1 is really just a negative 10. Last one on this page. I know that two negatives end up making a positive when we're multiplying and dividing, so I'm not even going to worry about the signs anymore. I'm just going to go ahead and change these to improper. 4 times 2 is 8. 8 plus 3 is 11. Keep the bottom on the bottom. 6 times 4 is 24. Plus 1 is 25. Keep the bottom on the bottom. So I'm going to double check myself because I'm already looking and I'm seeing on my diagonals that nothing reduces, which I hate. I love it when I can make the number smaller. So there's no shame in just making sure you haven't made a mistake. 2 times 4 is 8 plus 3 is 11. Nope, that's 11 over 4. 24, 25. Nope. So like I said, nothing on this diagonal. Nothing on this diagonal. That means my answer is not going to be able to simplify either. So across the top, I'm going to do 11 times 25, which we can probably do that in our heads. You know what? Because 25s, if you think of like quarters, there's 4 quarters in $1. So 11 of those would give me $2.75. So 275. And across the bottom, 4 times 6 is 24. You can leave it like that unless it's a word problem or unless you're told you have to convert it, or if it's multiple choice and all of your options are in mixed numbers. So if I convert that, now you know what? I don't necessarily know off the top of my head how many 24s fit into 275. So I'm going to pick up my calculator. And I'm going to do 275 divided by 24. I get 11 point blah, 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 blah. So I'm going to put 11. I don't care what that decimal is. I just needed to know that 24 goes in there 11 whole times. Then if I do 24 times 11, I get 264. So now I know 275 minus 264, there's 11 leftovers. So there's my answer. I didn't spend a whole lot of time here on dividing because it's almost the exact same thing. The only thing that's different is you have to flip the second fraction. My classes, we always say KCF. KCF, not KFC like the chicken, stands for keep it, change it, and flip it. I know some teachers are not a fan of that for various reasons. And I understand a lot of those reasons, but I also know that KCF, or keep it, change it, flip it, is an easy thing to get stuck in your head. And even sometimes when they're really annoying and in class, I'll tell the dumbest jokes or sing the dumbest little songs because I know they get stuck in your head. And then I know that you'll remember to do that when it comes quiz or test time. So keep it, change it, flip it. First thing I want to do is make any improper fraction or make any mixed numbers improper fractions. You can't start thinking about KCF until you have something over something. So this is really 7/8 divided by 2 times 1 is 2 plus 1 is 3 over 2. So now here we go. I'm going to keep it 7/8. I'm going to change it to times, and I'm going to flip it to 2/3. And now it's exactly what we were doing on all the other pages in this video. You can multiply straight across the top and bottom and then reduce, or check out your diagonals. 7 and 3 doesn't get any smaller, but 2 and 8, I can divide those by 2s and make this a 1 and make this a 4. And then across the top, I get 7. Across the bottom, I get 12. My quotient, my answer to this division problem is 7/12. Same deal on the next one. I need to make them something over something first. So 10 over 1 is the same thing. Still division just for now. Negative 5 times 2 is 10. Plus 1 is plus 3 is 13 over 5. Now that they're both something over something, I can keep it 10 over 1, change it to times, and flip it to negative 5 over 13. Do not cross reduce until after you flip it. Because while here the 5 and 10 reduce, when I finish setting up my actual problem, the 10 and the 5 are side by side, and you cannot reduce when they're side by side. I can't make the 1 and 5 any smaller. I can't make the 10 and 13 any smaller. So there's nothing I can reduce there. I know it's going to be a negative answer. How do I know that? Do you know? It's because my signs are different, right? One negative makes the whole thing negative. So multiply across the top. 10 times 5 is 50. And across the bottom, 1 times 13 is 13. It's reduced, so leave it if you're allowed. Or if you want to change it, I know it's negative. So here again, maybe you don't know off the top of your head how many times 13 will fit in there. So what you want to do is pick up your calculator and take 50 divided by 13. You're going to get 3 point blah, blah, blah. So I know it goes in there 3 whole times. If you don't know what 3 times 13 is, now take your calculator and do 3 times 13. You're going to find out that it's 39. So if I do, whoops, I just got a weird message on my Chromebook. I don't know if you guys could see that or not. I guess we're all good. So if I do 3 times 13, I get 39. 50 minus 39 gives me 11 leftovers. So negative 3 and 11 thirteenths. Last one, make them both something over something first. Don't start reducing, multiplying anything, no flipping until after you make them both something over something. I wish you guys could see me. Well, no, actually I don't, because I do really stupid things and I talk with my hands a lot. But every time I say something over something, I'm doing this dumb hand motion. My students know. Whatever. You got to laugh at yourself, right? So negative 5 over 6 divided by, I'm going to make that 15 over 1. Now that they're both a number over a number, I can keep it 5 over 6. I can change it to times, and I can flip it to 1/15. I can multiply across and across. Or if you look at your diagonals, 1 and 6 don't get any smaller, but 5 and 15, let's reduce both of those by 5. Let's make that a 1 and a 3. Across the top, you get 1. Across the bottom, you get 18. 1/18 for my answer. That is the end of this lesson, and that is actually the end of this unit for my classes. So if you need more help with 7th grade math, you know the drill. You see my YouTube channel there, Math with Luger. Please feel free to check it out. If you're one of my students or family member of one of my students, there's always updates on my classroom Facebook, Luger's Math Class. If you need to get in touch with me, there's my school email, or leave a comment here on the video. I will try to help you out the best I can. Thank you so much for sticking with me, and I hope this video helped you out.